our fourth problem, and it asks us to simplify the expression 1 plus tan squared x. There are two main ways that you can do it. The first way is actually really simple, because 1 plus tan squared x is already a really common identity, and that is called, and it is one of the more common Pythagorean identities. Although it's not the most common Pythagorean identities, but it is one of the more common trigonometric Pythagorean identities. So you can just say using the trigonometric Pythagorean identities. Usually you can just say Pythagorean identities or Pythagoras identities, that's fine in this context. But you can just say something like, using the trigonometric Pythagorean identities, we know 1 plus tan squared x is secant squared x. Okay, so that is the first way that we can try to approach this problem. And the second way is, that is weird. Just some bug with OneNote, probably. No? Okay, so let's just write our answer over here, in a spot over here, since most of the spots are kind of blocked by OneNote. So this is basically our solution number 1. This is completely fine. You can just say something like this, and you should receive full marks. And if not, you can also debate to your teacher about it, to be honest. But since they're asking you to simplify this expression, they're probably asking for like the proof of the Pythagorean identities, or like the entire, or like just the simplification without actually using the trig Pythagorean identities. So how do I do that? Oopsie. Let's just do, okay, let's just change this thing back to black, because blue, the entire thing in blue kind of looks awful if you think about it. Okay, this is our solution number 1. And let's do solution number 2, which is the actually proving this entire thing, or proving the trig Pythagorean identities, or one of the trig Pythagorean identities. So basically, we just need to simplify this expression. So first, let's rewrite the expression. Using the number 1 is, you can't really simplify 1 because it's just an integer, but we know that tan x is equals to sine x over, let's just say note, tan x is equals to sine x over cos of x. So we can substitute tan x into the tan x squared. So we have the 1 plus tan squared x is the same as 1 plus sine squared x, or 1 plus sine x over cos x squared. And for the record, tan squared x just means tan of x squared. But you see how you're writing tan of x squared like this? It's like a lot of effort and has a lot of brackets and stuff like that, and it's not as clean as just writing tan squared x like so. So that's why people just use this notation instead of the complete tan of x squared notation, but it basically means the same thing. So there's nothing really confusing about it. Okay, so now let's just pull the square sign inside. So we have sine squared x over cos squared of x, and now we have an integer plus an addition, or plus a fraction. So usually our next step is trying to find the greatest find the greatest common factor, or sorry, find the least common multiple between 1 and the denominator of this fraction. So like you can add those two up. And how do you do that? In this case, we have 1, and we want to change 1 to a fraction who has the same denominator as the fraction we have over here. So you want 1 to be a fraction that contains cos squared of x as its denominator while at the same time maintaining its value. It is actually quite straightforward because in this case we just know that cos squared over cos squared is 1 because 1 is, or any number over itself has the value of 1. So we just have cos squared x over cos squared x, which has the same value as 1, plus sin squared x over cos squared x. Now we see that both of our fraction here, this fraction and that fraction, they have the same denominator, so we can just add the numerator. So now we have cos squared x we have this expression is the equivalent as cos squared x plus sin squared x in brackets over cos squared x. Now we see this expression over here, and that should ring a bell for you because this is another one of our trig Pythagorean identities, where that identity states that cos squared x plus sin squared x is equal to 1. So in that case, we can just interchange cos squared plus sin squared x with 1 because they have the same value. So now we have 1 over cos squared x, 1 over cos squared x, and we also know that secant of x is equals to 1 over cos x whoopsie. We know that secant squared x is also equal to 1 over cos squared x. So we can also write 1 over cos squared x as 1 over cos of x squared. And we know that secant of x is equal to 1 over cosine of x. So we know this actually is the equivalent of secant of x squared. So this is how we simplify our expression of 1 plus tan squared x. And we arrive at a final result where 1 plus tan squared x is the same as secant squared of x. Perfect, that's how I simplify it. And now let's look at our sample solution over to our left. Oopsie. Okay, so our sample solution over here to our left, they directly used, yes, I guess they have it over here. Yes, they had the same simplification process as us. It's a little disorganized, but the solution is indeed correct. So let's just say the solution is correct. Yay! Perfect. Now let's move on to our next problem.